Now we are going to solve numericals of chapter 1, force. Question 1 says a nut is opened by a wrench of length 25 centimeter. If the least force required is 10 Newton, find the moment of force required to turn the nut. So here we find the solution of that. That is, distance given is 25 centimeter, which we change it to meter. 25 by 100, which is 0.25 meter. Then force given is 10 Newton, and we have to find out moment of force. So moment of force formula is force into distance, which is 10 into 0.25, that is 2.5 Newton meter. Then question number 2, we have, now we are going to solve question number 2. This is the diagram given. A wheel of diameter 2 meter. So diameter from A to B is 2 meter with axle at O. A force of 2 Newton is applied at B in the direction as shown in the figure. We have to calculate the moment of force about center O and at point A. So the information given in this question is diameter of wheel, that is 2 meter. So radius of wheel will be diameter by 2, that is 1 meter. And force applied at B is 2 Newton. We have to calculate with one moment of force at O. So force is applied at B and we have to calculate the moment of force at O. So this will turn this way, so it's clockwise movement, and formula is force into distance. So force is 2 Newton and distance from B to O is 1 meter, that is the radius. So it is 2 Newton meter. And for bit 2, moment of force at A, which is also clockwise, is force 2 Newton and distance from B to A is the diameter, that is 2 meter, which is 4 Newton meter. Now we are going to solve question number 3. In this question it is given that mass 50 kg mass is being lifted. So mass given is 50 kgs is being lifted by using a 1 meter long lever. So length of lever is 1 meter. If the length of the lever is reduced by 20%, so a reduced length of lever is 1 minus 20 by 100 into 1. 20% we are reducing, so it is 1  1 - 1 / 5, which is 0.5 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 - 1 4 by 5, 0.8 meters. This is the length of the reduced lever. This we are denoting it by R1, this by R2. Now we are going to find the gravitational force. Gravitational force is m into g. Mass given is 50 kgs. Acceleration due to gravity is 9.8 meter per second square, which comes to 490 Newton. Now, as in the question, it is said that how much more or less force is to be applied to achieve the same torque. We have to find the torque. Torque is force, that is force of gravity, which we have calculated, into the distance, which is 490 into distance is 1 meter, that is 490 Newton meter. In the question it says how much more or less force is to be applied to achieve the same torque. So in the second case also torque remains the same. So we will find the force. So torque is equal to force into the distance. This is 490 Newton. Force we have to find out, and now the distance is the reduced one, which is 0.8 meter. So force comes out to be 490 by 0.8, which is 4900 by 8, which on simplifying we get 612.5 Newton. Now the question asks the force, how much more or less force. So earlier force applied was 490 Newton. Now it is 612.5 Newton. So we will find increase in force. Increase in force is 612.5 minus 490, which is 122.5 Newton. Now we are going to solve question number 4. In question number 4 it says a mechanic applies a force of 100 Newton at the end of a spanner to tighten a bolt. The length of the spanner is 0.5 meters. How much torque is exerted on the bolt if the mechanic increases the force applied by 20% but holds the spanner closer at 0.4 meters? Would it result in increase or decrease in torque? So first we will find the torque. Torque is force into the perpendicular distance. So here in the original case force is 100 Newton and point of application of force is 0.5 meter, which comes out to be 50 Newton meter. This is in the original case. We can represent it as tau 1. Okay. Now in the next case, mechanic increases the force by 20%. So here the increased force is 100 plus 20 by 100 into 100, that is 120 Newton is the force. And the new distance is, point of application of force is 0.4 meter, closer by 0.4. The mechanic increases the force but holds the spanner closer at 0.4 meter. So distance is 0.4. Now in this case torque is 120 into 0.4, which is 48 Newton meter. This we can present it as tau 2. Now the question says, would it result in increase or decrease in torque? Original torque was 50 Newton meter. Now after the increase in force, it is 48 Newton meter. So the result is that the torque decreases by 50 minus 48, that is 2 Newton meter. Next, question number 5. A steering wheel of diameter 0.5 meter is rotated anti-clockwise. So let us do the diagram. This is the steering wheel of diameter 0.5 meter is rotated anti-clockwise. This is the direction of rotation, this way. By applying two forces, each of magnitude 6 Newton, draw a diagram to show the application. So it is this way, it is moving, 6 Newton force is applied. This way it is moving, this direction force is applied, 6 Newton. And diameter of the, now let us write the given information. Diameter of wheel is 0.5 meter and radius is diameter by 2, that is 0.5 by 2, which comes out to be 0.25 meter. Now force applied is given, force is 6 Newton. So it asks you calculate the moment of force applied. So moment of force is force into the distance. Force is 6 Newton and the distance between the application of force is 0.5 meter, which is 3 Newton meter. Now next question number 6 we are going to solve. This is the diagram given in which two forces are there, F1 and F2. F1 is 5 Newton, F2 is 3 Newton. Acting at points A and B on the rod pivoted at point O, such that OA is 2 meter and OB is 4 meters. We have to calculate the moment of force, F1 about O, F2 about O, and total moment of the two forces. So bit 1 is moment of force F1 about O. Moment of force F1 about O is force into the distance, that is OA. So force is 5 Newton and distance of OA is 2 meter. So it is 10 Newton meter anti-clockwise. Then bit number 2, moment of force F2 at O is force into BO, the distance BO. So force this side is 3 Newton and distance BO is 4. So it's 12 Newton meter, and this is clockwise. Now in bit number 3, it asks total moment of force at O. Total moment of force at O. So it's clockwise moment minus anti-clockwise moment, which is 12 Newton meter minus 10 Newton meter, which is 2 Newton meter clockwise. This is more